So, good morning to all.
Good morning, ma'am.
Good morning.
Morning.
Good morning. So, shall we start or we wait some more minutes?
Can start.
How many students in your batch?
936.
136. So, shall I wait or shall I start? Oh,
We can start.
okay. So, what about the last practical? What are the things we studied in the last practical session?
Determination of transpiration by cobalt chloride sheet.
Okay, determination of transpiration by cobalt chloride sheet and two practical we did know.
Determination of transpiration by a 4-leaf experiment.
Yes, 4-leaf experiments. So here also we will look on the transpiration. Okay, the demonstration, the rate of transpiration by using the Ganongs photometer. Okay, so what do you understand about the transpiration? Transpiration?
The loss of water from the aerial part of the plants in the form of water vapor.
Yes, the water loss as a vapor form from the aerial part of the plant to atmosphere. That's a transpiration. Okay, in the vapor form. Okay, that's important. Okay. So what's the difference between the guttation and the transpiration?
Guttation is a water form, liquid form.
The guttation,
Transpiration is a
both phenomenon that will be caused the water losses. But in case of the transpiration, water loss as a vapor form. But in case of the guttation, water loss along with the minerals as in the liquid form. Okay, that's a guttation. Okay, so let's we move on our today topic that demonstrate the rate of transpiration by using the Ganongs photometer. So what do you know about the Ganongs photometer? Based on your school level knowledge, Ganongs photometer? Did you know that before?
No, madam.
No. You didn't study during the school level. Is it? Anybody please response? You didn't study.
studied, ma'am.
Study. Okay. So the today objective to demonstrate the rate of transpiration by using the Ganongs photometer. So you know practical written books that should have some orders. Introduction, objective, material, methodologies, no, isn't it?
Yes, ma'am.
Yes, but in here, after the title, I put on the objective. So that's your work. That this introduction, that's your work. What are the things you should discuss or they introduced as this practical? Okay, I didn't put any introduction in here. That's your work. Okay, please note something related to the transpiration and Ganongs photometer in the introduction part. So the objective to demonstrate the rate of transpiration by using the Ganongs photometer. For this practical, this is the setup. This is the setup. Ganongs photometer. For this, we want knife, forceps, and Ganongs photometer setup, Vaseline, stopwatch. Okay. These are the things we want to do this practical. Understood?
Yes, ma'am.
Yes. Okay. Then Ganongs Potometer. So can anybody of you tell about the Ganongs Potometer? How can you do this practical? Any idea? Okay, I'll put the procedure. First you read and try to understand, then after I will explain. Okay. Okay, this is the procedure of this practical. Better to read and try to understand. Then after I will explain. Okay. Is it okay? Shall I change?
Yes.
Okay. Okay, this is the diagram. So any one of you can you explain based on your knowledge? Anyone? Any one of you? Can you? Hassini? Hassini 2020 AG024? Has any idea? So anybody else can you try? What's the setup based on your reading? Can you explain anyone?
Ma'am, can I try now?
Yes, yes, you can.
First, we want to fill this Ganongs photometer in water,
Okay,
with water. Then, one side we hold the plant, plant part with the leaf,
okay,
and another side we dip in the water beaker.
okay,
Then we want to make a air bubble in the capillary tube,
okay,
and we want to put the setup in under the sunlight.
okay,
Then we want to measure the water movement, uh, water movement in uh, uh, water movement measurement with
bubbles
the time.
movement. Okay,
Bubbles movement with the time, and repeated this experiment again and take a more reading.
okay, good, fine.
Thank you.
Okay, so this is the Ganongs photometer setup. In here, first, okay, the first in this whole setup should be submerged into the water. which means under the water, this setup should be put it into the submerged condition first. Why? Why? First, this setup should be put it into the water because to remove all the air bubbles. That's why. Okay. So in this setup, that should be put it into the water, the submerged condition. Submerged condition. Okay. Understood? To avoid the air bubbles into this setup. Okay. Am I correct?
Okay, ma'am.
Okay. Then we have one shoot. Shoot is there. Okay, the plant shoot. In this shoot, that should be cut it into the slant position and put it into the cork. This is the cork. Okay, this is the cork. So this slant cutted shoot that should be inserted into the cork, and that cork with a shoot that will be placed at the end of one tube. In this tube, we should place this shoot with a cork. Okay, so in here we should cut the plant shoot as in the slant position. Why?
Increase the area.
Yes, good. In here, if we cut it in this slant shoot in this type and this setup. In here, the surface area will increase in the slant cut. So that increase the xylem vessels. What's the xylem vessels?
Which transport the water.
Yes, good. So in that xylem vessels, that will be transport the water as well as the minerals throughout the plant. So in here, if we cut this plant shoot in the slant position, where that will be access more water intake through the xylem vessels, because that will be induce the more water intake by using the xylem vessels. Okay, if the water intake will high, then after the transpiration that also will high, no? If the availability of water is high, the transpiration rate also high, isn't it?
Yes, ma'am.
Yes. So if you cut this shoot in the slant position, that will be induce the water intake in this manner, that will be excess or increase the transpiration rate. Okay. So that is a second step. First, the setup should be submerged into the water, and second stage, the shoot that should be put in or cut in slant position and put it in this cork, insert in the cork and place in this one edge of this column. Okay. Then we have in this setup the reservoir. What's the purpose of this reservoir? Okay, I'll tell that one later. Then the third setup, now we have these tube, reservoirs and capillary tube, and in this capillary tube that should be placed into the water filled beaker. Okay, this capillary tube that should be placed into the water filled beaker. So if possible, we can put it in the color water also in the beaker. If possible, you can. Okay, understood?
Yes, ma'am.
Yes. Then after and slightly we can uplift this capillary tube to expose the environment and allow only one air bubbles into this capillary tube. Okay, slightly uplift this capillary tube into the environment and allow only one air bubbles into this capillary tube. Only one air bubbles. Then after again we can place this capillary tube into the beaker. Okay, is it clear? All four steps, is it clear?
Yes.
Yes. Then after we can make this setup according to our needs into the table or any benches. Okay. According to our needs, we can place this setup on the table. Afterward, now we have the air bubbles in here. Okay. So afterward, we can place this setup into the sunlight. Okay, to allow the transpiration. At the time, we can note the air bubbles position. In here, we can have the measurement. So according to that, we can get the measurement of air bubbles. Then after some interval time, 5 minutes or 10 minutes later, we can again take the reading where the air bubbles are there. Okay, what do you think about the air bubbles movement will be this direction or this direction? This or this? A, B. Which direction?
A direction.
Yes, why?
Because when transpirating, the plant absorbs, the stem absorbs water.
Yes, in here, good. In here, the transpiration occurs. So, according to the transpiration, where the plant xylem that will be intake the water. So, the water that can be moved from to through this capillary action to this. Therefore, the bubbles also move in this direction. A direction. Okay. The first in this setup that should be placed in the submerged condition to avoid the air bubbles. Then after cut these shoots in the slant position to increase the surface area. If the surface area will increase, the xylem vessels can take more water and nutrition. Okay. Then after in this setup, then after we can place the beaker at the end of the capillary tube. The beaker that will have the water, if possible, we can go for the color water also for our clear observation. Then we allow this capillary tube in uplifted and allow one air bubbles that will be enter into this capillary tube. Then the setup that will be placed under the sunlight and note the initial point of air bubbles and allow some time to move or some time for the transpiration. At the time, the air bubbles can move through this shoot direction. Okay, in this way we can take repeat reading. Okay, so from that now you can say what's the purpose for this reservoir. What's the purpose for that reservoir? What's the purpose? So initially you have the air bubbles in here. At the time of transpiration, air bubbles movement in this direction. So now after 5 minutes later, you have the air bubbles in here. Then you can take reading again, no? Yes or no?
Yes.
Yes. Repeat reading. You can take and get good transpiration rate, accurate transpiration rate. So in here now you have the air bubbles in here. Again, this air bubble should be go into this area. Therefore, the reservoir that can be open this and allow the water movement in this direction. So the air bubbles movement can move in this direction. Okay.
Okay, ma'am.
So after first time, first reading, at the time you can get the air bubbles in here. Then after you want to do again the practical. Therefore, you can open this reservoir water and allow the air bubbles movement from to here. So in here, now the air bubbles is here. Then you can take another ring. Okay. So that's the purpose of reservoir. All of you understand?
Yes, ma'am.
Okay. Any doubts? All of you understand first, or I may repeat again.
Understood, ma'am.
Okay. So in here, some other precaution we want to take while doing the practical. Any guesses or any idea? So the first, as we mentioned earlier, the should be, if possible, we can get the stand position. So if you get the slant position, where it will be induce the transpiration. Therefore, in the short duration time, the water movement, the bubbles movement can move long distance in the shorter time. Okay. Okay, if possible, we can make a cut as a slant position. Then in here, we want to analyze the transpiration through the stomacher, no? Yes or no?
Yes, ma'am.
Yes, but some possibilities are there. The water that will be evaporate, isn't it? This is an open setup now. So then the water also evaporate through this area and this area. Therefore, we can smear the Vaseline in this area to avoid the evaporation. Okay, if the evaporation occur from here, the water also move in this direction, no? Yes or no? So
Yes,
that also contribute the air bubbles movement. Not only the transpiration, the evaporation also contribute. So to avoid the evaporation reading, we can place or smear the Vaseline on this area, the open area, the environmentally open area, we can smear the Vaseline. In here, we place some oil. Okay, through the oil, the water that can't evaporate. Okay, so the open area, we can smear the anti-transparent agent, the Vaseline, oil, okay, grease. Okay, we can place it. Okay. Okay.
Okay, ma'am.
Okay. So then we get the shoot. No, the shoot should be in the fresh form. So if you get the shoot that have loss of vigor or the loss of their freshness, that also affected this experiment, because if the fresh shoot that have the alive cell, because in here no any root systems is there, isn't it? Only the shoot. So that can survive or in the fresh form or some of the time. So therefore, if the shoot that not in the fresh form, yeah, the cells are go for the dying stage. So if the dying stage means there are no any metabolisms occur. The metabolism, that's one is the transpiration. So the transpiration rate will be reduced. Okay. If the shoot that not in the fresh form, where the number of cells will be dying. Okay, so no any metabolism. No any metabolism. Metabolism is no any transpiration, respiration, photosynthesis occur. So the no transpiration means, or the less transpiration, that also affect the air bubbles movement. No. So if possible, we can get the fresh leaf or shoots. If the leaves, the shoot have more leaf, that also good, because the number of area that will be exposed to the sunlight to access more transpiration. Okay, here we allow more transpiration, then only the water or the air bubbles movement will be can move long direction in a shorter time period. Okay, that's why we can go for the more leaves in the shoot, and also the shoot that should be in the fresh form. Okay, is it clear?
Yes.
Yes. Then in here we take one air bubbles. If you go for the 2 or 3 air bubbles, that also affect your readings. Only take one air bubbles. Please consider that one air bubbles only. Okay. So if possible, you can go for the color water, because if the color water in here, that's water. The water that's transparent, no any colors. So at the time of transpiration, the water that can be move into this area. This is the air bubble. So in this area that have different color. Then if you can't see your naked eye in the air bubble, that not a clear visible one of just the air bubbles. This also in a white in color, and the air bubbles also not white, they transparent. So sometimes you can't see clearly. That's why if you go for the color water, in this area have one color, no any color. In this area have the color. So that's why you can easily get the reading, no? Isn't it?
Yes, ma'am.
So in this direction. Sorry. So if the body transpiration occur, you can get this area reading, because the color is in here. So like that. Okay, if possible, you can go for the color water. Okay, it's fine. Is it okay?
Yes, ma'am.
Okay, so now you can say what will be the observation. Observation.
Air bubbles form.
Yeah, good. The observation is nothing. That air bubbles that can be moved in this direction through the shoots. Okay, the air bubble movement through the shoots. Okay, that's the observation. Air bubbles move towards the plant shoots. Then reading and calculation. So in here, in the 5 minutes interval time, we can take the reading. So the initial reading, the air bubble initially that it is the 0.5 centimeter. In here, the air bubbles initially that is in the 0.5 centimeter. Then after 5 minutes later, the air bubbles that can be in the 5.9 centimeter. So what do you expect? The distance that will be air bubbles will move. Can you calculate? In here, during this practical, we can take the reading at the time of 5 minutes interval. Okay, in 0.5 centimeter. After 5 minutes later, the air bubbles move, and in that position, 5.9 centimeter. So from that you can get the reading, the how long the air bubbles move during these 5 minutes time. Isn't it?
Yes, ma'am.
Yes. So can you calculate? Distance where the air bubbles move during these 5 minutes interval. So the final reading 5.9 minus initial reading 0.5 over, no, not over, 5.4 centimeter the distance. At the time of 5 minutes time, the air bubbles move 5.4 centimeter. Again, you can open the reservoir to move the air bubbles from to the initial point, that 0.5. Now the air bubbles in the place of 0.5 centimeter. Then that should be allowed for the transpiration under the sunlight during the 5 minutes time. After 5 minutes time, you can see the air bubbles is in the position to 6.2 centimeter. Now you can get the reading. The distance of air bubbles move throughout these 5 minutes time. Final time minus initial over time period zero point 0.2. So the distance traveled, the air bubbles during the 5 minutes time is equal to 6.2 minus 0.5 equal to 5.7 centimeter. Is it correct?
Yes, ma'am.
Okay. So can you calculate next four readings?
3.
So the calculation part or the procedure you want again. One person asked to repeat again. So calculation part or the procedure? Okay, procedure. Okay. Okay, I'll go back again. Go to that procedure part. Yeah. Wait just 2 minutes time. Okay, some person asked about this practical procedure. So that's why I will explain again. Okay. So this is the Ganongs Potometer to calculate or the measure the transpiration rate. The Ganongs that will be that the Ganongs that scientists that invented this apparatus. Therefore, this apparatus we can call as the Ganongs Potometer. So when you are writing this name, consider the photometer. Okay, not photo. Okay, consider this one. Okay, this is the correct. It's not. Okay, while you are writing this name, please consider. And this is the Ganongs meter setup. In here, we have capillary tube and two water reservoir setup. So the first we want to support this setup into the water to avoid the air bubbles entering. So in this setup, initially that not have any air bubbles. Therefore, we should place this setup into the water. Okay. Then after, now we have one plant chute. Okay. In that plant chute, that should be inserted into one cork, and that cork should be placed into this edge of this water tube. Okay, the cork with the chute that should be placed into this water tube. Afterward, we can place the beaker with the water. If we can colored water, that also we can use. If you use the color water, that's good. Or the efficient or that accurate reading we can get. Okay. So in here we have the color water. The color water where the capillary tube that should be immersed in this color water. After some times later, we can take out this capillary tube to expose the environment, because to allow the air bubbles entry through this capillary tube. At the time, we can ensure the only air bubbles entry is there. Okay. Afterward, we can place this setup under the sunlight, and at the particular time interval, note the air bubbles movement. Initial air bubble movement, and after 5 or 10 minutes or 12 minutes later, the air bubbles moved. So from that you can get the distance of air bubbles movement at the particular time. Okay, this is the Ganongs Potometer experiment. At the time of this experiment, you can consider that water only lost through this chute at time of the transpiration, not evaporation. So the water loss occur in two ways in here, the evaporation and transpiration. But our aim is water loss through the transpiration calculation. This. Therefore, we can put some grease or vaseline or the oil that are the anti-transparent agent that not allow water losses through this reservoir. Therefore, we put some vaseline or oil around this area. Okay, and this one also, because this area have the waters. Okay, water also evaporate through this setup. Okay, and another person asked what the purpose of the reservoir. Okay, you know, during this 1 to practical time, you didn't take only one reading. You can take minimum 2 readings to get the accuracy, the average of the experiment result, isn't it?
Yes, ma'am.
Yes. So like water potential time also you can take 2 strips of potato like that. So that's why initially the air bubbles is there. After 5 minutes, air bubbles in here, assume in here. Then after, if you allow 5 minutes time, the air bubbles movement in this direction. So but in that time, you can't calculate or the measure. Therefore, this the air bubble should make in this position again. That's why the reservoir that will be open, that should be open and allow the air bubbles movement in this direction from here to here. Then allow again 5 minutes time how in this, which direction the air bubbles movement will be there. That's our observation. Okay. Now is it okay? Is it okay now? Okay. Okay. So afterward, the observation, the air bubbles movement from sorry, in this direction to this direction, which means through the shoot direction, because in here the transpiration occur in this direction. Therefore, the xylem vessel absorb the water and air bubbles move through this. Take the water in here and move the air bubbles in this direction. So the observation air bubbles move towards the plant shoots. Then the reading, first we can take initial reading that's same because they're not a calculated one. No? We assume the initial reading that's same 0.5 centimeter and during the 5 minutes time, the final reading that should be 5.9 centimeter, which means initially the air bubbles is there. I enlarge this image. This is the ruler or measurement. Initially air bubbles is here. After 5 minutes time, air bubbles 5.9 centimeter. Okay. Initially 0.5 centimeter. So the distance that will be 5.9 minus 0.5 equal to 5.4 centimeter where air bubbles move. Okay. That's this. From that one, you can calculate the distance traveled by the bubbles. Okay. So 5.9 minus 0.5 equal to 5.4 centimeter. In here, 6.2 in minus 0.5 into 5.7 centimeter. So in here, what's the answer? Answer?
4.3.
Okay. Here?
6.6.
6 centimeter. Okay. Here?
4.4.
4 centimeter. Here?
5.1.
5.1 centimeter. Okay. You understood. Then we want to calculate the rate of transpiration. So the rate of transpiration means you have the distance traveled by the air bubbles. You have. Then that should be divided by the time. The 5 minutes time duration you have. Then, so 5.4 centimeter over 5 minutes equal to 1.08 centimeter minutes minus 1 for this. So what do you think about this one? What?
5.7 over
Okay.
5.
Okay, answer?
1.1.
1.12, no? Yes or no? Yes or no? Is it wrong?
1.14, ma'am.
1.14. Yeah. Then again, 4.3 distance travel over time 0.86. Then here the distance travel by the bubble 6 over time 5 equal to 1.2. Then the distance travel 4 centimeter or 5 minutes time 0.8. And here 5.1 over 5 centimeter, 5 minutes 0.02 centimeter minutes minus 1. Isn't it?
Yes, ma'am.
Yes. So in here we calculate the unit centimeter over minutes. We can go for the centimeter over second also. Therefore, centimeter 1 minute equal to 60 seconds. No? We can go for this one also. If example, in this one we can take this one 5.1 centimeter over 5 into 60. That will give the centimeter second minus 1. If you calculate this one, you can get this reading. Okay?
Okay, ma'am.
Okay. So, this is the calculation part. And one person asked the question, during the time period, the transpiration is constant or not? That not constant because according the transpiration that it will affect the sunlight, humidity, wind, many other reasons are there. Light intensity also there. So during the time period that not constant. Therefore we can go for the average. That's why we can take more reading. In the 5 minutes time, the transpiration rate will be 1.08 centimeter minutes minus 1. After 5 minutes, you can see 1.14 centimeter minutes minutes minus 1. After 5 minutes, you can see 0.86. That not a constant, that not increase or that not decrease. The decreasing rate or increasing rate, that also not constant. Intermediate time that will be increase or sometimes decrease. Therefore, in here the 30 minutes time, we can calculate the average. Okay. Therefore, in here that we have the distance travel by the air bubbles movement. So in the 30 minutes time, therefore we can calculate this one as a summit. 5.4 plus 5.7 plus 5.3 plus 6 plus 4 plus 5.1. These are distance travel by the bubbles throughout the 30 minutes time. And that will be again divided into 6. Okay, in this 6. 1, 2, 3, 4, 5, 6. And that will be give the distance traveled by the bubbles at the average value. Okay, understand?
Yes, ma'am.
Okay, so in here for the accurate reading, we can get the average distance. Okay, so that will be give the 5.084 centimeter. Then we can go for the rate of transpiration at moreover the accurate rate. Now we have the 5.084 centimeter distance over 5 minutes time. So what's the rate of transpiration? 1.0168 centimeter minutes minus 1 or 0.017 centimeter per second because 1 minute is equal to 1 second. Sorry, 60 seconds. 1 minute equal to 60 seconds. So 1.168 over 60. Okay, that will be give 1.7 centimeter second minus 1. Okay, all of you understand?
Yes, ma'am.
Okay. And one person asked that same constant. Now you can understand, I think so. Okay. Then this is your practical session. So in your discussion part, you should discuss what will happen the air bubbles movement when the photometer kept under the sunlight. In here, the photometer room, I will change and send this slide again. Okay. the sunlight, dark condition, shade condition, and wind fellow. So what do you think about that? Air bubbles movement, the velocity, the sunlight at the particular time, what will happen? Sunlight. When your photometer exposed to sunlight, what will happen?
Air bubble movement is fast. Then
Yes, because at the sunlight that induce the transpiration. The transpiration increase, then the air bubble movement move fast at the particular time interval compared to the dark condition and the shade condition. And at the time of wind fellow also induce the transpiration rate, so the air bubble movement fast. Okay, that should discuss yourself in the discussion part. I just explain only for your understanding. So then precautions. In here we already took that all set up in the under the water and cut in the slant position, and the shoot should be in the fresh form because at the fresh leaf that have the metabolic activity effective one. The metabolic activity is one of that one is transpiration. So the transpiration also effective. So the air bubble movement we can see. Therefore we can use the fresh cut leaves. Then they should have the number of leaves because transpiration induce the number of leaves, and Vaseline, that's a anti-transparent. So if they apply the Vaseline or oil or grease, that will be reduce the evaporation through the photometer. Okay, so we can ensure the photometer, the water loss only through this transpiration through the stomata. So that's why we can use the Vaseline, apply the whole joint. And we can use the color water for the clear observation and ensure that water bubbles, only one bubble we can take within the capillary tube. So these are some precautions. In these precautions, we already discussed during the practical session. Ma'am, slang position, ma'am. Slang position is just been slant position. Okay, that somewhat not in the horizontal or not in the vertical, somewhat like that. The slant position. So assume my drawing also the slant. Okay, assume this is the shoot. Okay, so you can cut in this direction or you can cut the slant movement. This is the slant. Okay. 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 So any doubts regarding this practical, the precautions or the observations, procedures, calculations? Any doubts? All of you understood?
Yes, ma'am.
Okay, fine. Then your discussion, you should discuss what are the limitations to choose this experiment. The Ganongs Potometer experiment, what are the limitations are there? Please discuss as yourself. Okay. So please discuss this one in the discussion part. So the air bubble movement, velocity, and the precautions, limitations. This is your work in the discussion, and also you should write the introduction part as yourself. If you have any doubts, you can ask. That's all about today practical. So if you have any doubts, you can ask. Otherwise, you can leave. And one more thing, one person didn't do the presentation, the session 2. You can do it now. And session 2, I think 3 practical presentation remaining. You can go to the presentation link, the Nilusha's link. I think they already sent on Friday. At the link, you can join for the presentation, the session 2 presentation. Okay, session 3, you can stay in this same link. Only one presentation. So others, if you have any doubts, you can ask. Otherwise, you can leave or you can stay until the